So we got greatest common factor down. Let's look at least common multiple, which is kind of its counterpart. And we'll break it down, or we'll break down these three words just like we did with greatest common factor, just to really understand what this concept is. So a multiple is a number that you can count by. So for example, multiples of 2 would be 2, 4, 6, 8, 10, 12, 14, 16, 18. Multiples of 9 would be 9, 18, 27, 36, 90, right? And all the numbers in between if you continued to repeatedly count by 9. So that's what a multiple is. Just think of counting by a number. All right. Common, again, something that's shared between two things. And then least is the smallest. So we are looking for, when we're finding the least common multiple between two or more numbers, we're finding the smallest number that all those numbers that we're comparing, you can each count by them to get to that number. So as an example, let's take 3 and 7. What is the least common multiple between 3 and 7? Well, let's just count by 3 to start. So multiples of 3 would be 3, 6, 9, 12, 15, 18, 21, 24, 27. We can keep going. And then multiples of 7 would be 7, 14, 21, 28, 35. Well, where are there common multiples between each of the numbers? Well, I see both. If I count by 3 and I count by 7, eventually I'm going to hit 21 on each of them. And there's no smaller number than 21 where we have a common multiple. So our least common multiple between 3 and 7 is going to be 21. And if you noticed, one kind of helpful trick to figuring out what the least common multiple is count by your larger number first. So you see how 21, when we counted by 3, was all the way over here to the right, and the 21 for the 7 happened a little bit sooner. So you can kind of save some time if you figure out what multiples of your larger number you'll have. That way you don't have to count so far down the line. But let's do some examples so we can drive the point home. All right, the least common multiple of 11 and 2. So I'll just count by each of the numbers and see what is the smallest multiple between the two. So for 11, we got 11, 22, 33, 44. I can keep going if I want, but I'll stop there. And then 2, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 22. So I'm going to stop there because I see both 11 and 2 have multiples, or 22 is a multiple of both 11 and 2. It's the smallest one. The only number that we could test to see if it would be smaller would be 11, but 11 is an odd number, and you can't count by 2 to get to 11. So our least common multiple of 11 and 2 is 22. All right, least common multiple of 20 and 25. So I'm going to use that trick. Let's just look at the larger of the two numbers. So I'm going to write multiples of 25. So we have 25, 50, 75, 100, 125. I'll just keep it at that. And now think, can 20 go into any of these? Well, evenly, I should say. Can 20 go into any of these 5 numbers evenly? 20 cannot go into 25 evenly, so that's not it. 20 can't go into 50 evenly. You got 20, 40, and then 60, so we skip over the 50, so that's not going to work. If you notice, when you count by 20s, all your numbers end in 0, so 75 is not going to work, but 100 will. 20, 40, 60, 80, 100. So our least common multiple of 25 and 50, or 20 and 25, I should say, is 100. All right, for the least common multiple of 4 and 12, you can use prime factorization to figure out the LCM as well. So I did a video on that a couple of videos before, so go watch that if you haven't seen it yet. So if we do prime factorization on 4, we'll get 2 times 2. If we do it on 12, we'll get 6 times 2, and then that 6 can split down into 3 times 2. So if we kind of find what's common between the two, so I got a 2 here, a 2 here, and then I have a 2 here and a 2 here. You see, I've made 2 pairs of 2. So I'm only going to take 1 2 from each of the pairs. So what I mean by that is over here I got 1 2 in yellow, and then another one over here in yellow. I'm just going to take one of them. And the same thing with the ones in green. I got 1 2 over here, and then another 2 over here. I'm just going to take one of them. And then the other prime number that we had is this 3 here. So I'm just going to add that to the end there, and we're going to multiply these 3 numbers. And we'll get 2 times 2 times 3 is 12. So that's our least common multiple. If you wanted to do it the way that we've been doing it before, just counting it out, we can do that real quick. So multiples of 4 would be 4, 8, 12, 16. If I need more, I'll write more, but I'll just start there. 12 is going to be 12, 24, 36. And we can see that 12 is the first number that they have in common. It's the smallest. It's the least smallest number, or least common multiple that they share. So we can see that the least common multiple of 2 numbers can be one of the numbers itself. So again, 2 different ways to do it. I'll probably do this method here in the next examples as well, but our least common multiple is 12 in this example. All right, for finding the least common multiple of 25 and 3, let's do that prime factorization trick again. So 25 can split into 5 times 5. Those are prime numbers. And then 3, well, it can only split into, I guess, 3 times 1, but we really don't even write this, so we'll just leave it as 3. Actually, let's leave it as 3 times 1, just so they look kind of similar. I see no pairs of numbers that are common between 25 and 3, or factors of 25 and 3 that I can circle like I did in the previous example. So what am I going to do here? Well, I'm just going to multiply all of these numbers. I'm going to do 5 times 5 times 3 times 1, which is going to be 75. So our least common multiple is 75. Again, if you want to see it written out, let's do 25 multiples of 25. It's like counting quarters, so 25, 50, 75, 100. And multiples of 3, right, we're going to 3, 6, 9, 12, 15, 18. And you can see it's already going to take a while to even get to see if 25 is a multiple. It's not. 50 is not a multiple, but if you think about how many times did we count by 25 to get to 75? Well, that was 1, 2, 3. So, and we can, if you know your multiplication, 3 times 25 is 75. So if we counted by 3 25 times, we would get to 75. But when you're working with large and then a large and a small number, sometimes it's just better to do the prime factorization trick, or just know your multiplication facts. All this is really easy if you know your multiplication facts forwards, backwards, left and right, inside and out. All right, the least common multiple of 60x squared and 40x. So when we introduce variables into terms, like this x squared here and the x over here, you'll hear these terms called monomials. I'll write that out. Monomials. So it's just one term. 60x squared is considered one term, even though there's a variable and a number. But just so you, if you see that, you know what we're talking about here. But use prime factorization for these. it's the easiest to figuring out least common multiple when you have variables involved. So I'll take 60. I'll just look at the number part first. So 60, when we prime factorize it, well, let's see if we can cut it in half. So 2 times 30. And then 30 can be 2 times 15. And then 15 can be 3 times 5. So we'll have 2 times 2 times 3 times 5. And then this x squared here, well, that's just x times x. So I'm going to slap that on at the end there. And then looking at this 40, right, it's an even number, so we can do 2 times 20. 20 can split up into 2 times 10, and then 10 can split up into 2 times 5. So I will write 40 in its prime factorized form as 2 times 2 times 2 times 5. And then we have multiply by x at the end there, so I'll just do times x. All right, so let's find some pairs, kind of like we did a couple examples ago. So I see a 2 over here and a 2 over here, so I know I'll have 2 in my least common multiple. I got another 2 over here and another 2 over here, so I'll have another 2. We also got this 5 and 5 here, so 5. And then the 3 and the 2 over here, right here and right here. Actually, I'll do it in blue. The 3 and the 2 here. Since they can't pair up with anything else, we're just going to include them in this multiplication. And then looking at the variables, we have an x over here and an x over here, so I'll just add an x. And then this this last x hanging out by itself, we're gonna include him as well. So if you multiply all of these terms together, you'll get your least common multiple. So 2 times 2 is 4, times 5 is 20, times 3 is 60, and then times 2 is 120. And then we'll have x times x, which is x squared. So you might be looking at this answer and say, okay, well, I see that I got an x squared here, and I guess that's coming from the 60x squared because it also has one, but why is that in my answer if there's not an x squared next to that 40? It's just 40x. We'll plug in a value for x and then run the problem back again, just working with numbers instead of numbers and variables. So for example, if we make x equal to 2 right here, and I write this as, instead of 60x squared, well, I'll write it as 60 times 2 squared. And we know that 60x squared, its prime factorization is written right there. So I'll just rewrite this 2 times 2 times 3 times 5 times, instead of x times x, I'll just write times 2 times 2, and I'm going to keep that in parentheses. And then for 40x, I'll have 40 times 2, and that prime factorization is here. Again, replace the x with what we decided to substitute in for it, which is 2. So we'll have 2 times 2 times 2 times 5, and instead of times x, we'll have times 2. All right, so now we'll make pairs of numbers again, just like we did before. So I got a 2 over here, a 2 over here. So I'll have 2 in my least common multiple, a 2 here and a 2 here. So I'll put another 2 there. This 3, there's no matching 3, so we'll just stick it in. The 5 has a match, so we'll put a 5 there. All right, and then this 2 over here, it could match with this this 1 in parentheses, but I'm not going to put that in just yet because we want to kind of keep the parentheses by themselves since they were a variable before. So this 2 doesn't have another 2 outside of the parentheses to match with, so we'll just add it in as well. And then looking at the 2's in parentheses, we got 1 here, 1 there, so I'll add that 2, and then just 1 hanging out by itself. So we'll do times 2 at the end. All right, now no variables, we're just working with numbers. So let's see, 2 times 2 is 4, times 3 times 5 is 15, times 2. And then we have times 2 times 2. 4 times 15 is 60, and then times 2 is 120. And then we have 2 times 2, which I'm just going to write that as 2 squared. And the reason why I'm going to write that as 2 squared is that this sure does a lot look like 120x squared, the answer we got before when we just were working with the variable. So you can, of course, multiply that 2 squared out, get 4 times 120 is 480, and you'll have a actual number for your LCM. But it just goes to show you that yeah, even if you don't have an x squared in one of your terms like we did up there, it's possible it could show up in your answer like that. And here's the reason why. Again, so if you're unsure when working with variables what is going on as you're doing them, plug in some numbers and try to do it the same way and see if you can notice some patterns. All right, last one, finding the least common multiple of 9a squared and 18ab squared. So do prime factorization. So 9a squared, well, that's going to break down into 3 times 3. Can't break those down anymore. I remember we have this a squared, so I'll just do times a times a. 3 times 3 is 9. A times a is a squared, which is what we have to begin with, so that looks good. All right, 18ab squared. Well, the 18 is going to break up into 9 times 2. The 9 breaks up into 3 times 3. So we'll have 3 times 3 times 2. And then just add your variables, times a, times b, times b. Make your pairs. So I got a 3 here and a 3 here. So I'll put a 3 in my least common multiple. I got another pair of 3s, so I'll add one more 3. This 2 is unpaired, but we'll add it in anyway. We got an a over here and an a over here, so we'll add an a. And then this a is hanging out by itself, but we'll include it as well. And then these 2 b's are not paired with anything in this prime factorization to the left, but we will include them as well. And now if we multiply everything out, left to right, 3 times 3 is 9, 9 times 2 is 18. And that checks out because the least common multiple of just 9 and 18 is 18. Write it out if you need to. And then a times a is a squared, b times b is b squared. So again, even though this term, the 9a squared, didn't have a b squared, and this 18ab squared didn't have an a squared, both a squared and b squared showed up in our answer. And again, plug in numbers to see that, that it does work this way. Kind of a tricky concept, but the more of these that you do, the easier that it gets.